Welcome to my channel. Today I will tell you how to repair this board step by step. The thing to keep in mind here is that people show you by making a board, but the secret is how to make it. They keep a secret. Here I will make you this board using schematics and body, and I will share with you every step of the repair. If all is well, watch my video. So let me tell you its conditions. So here I put the charger on it. So here I put this charger on it. And after installing the charger, you can see our ampere, which is 0.001 is coming, 0.011 is coming. So here I also shoot the jumper of the keyboard, which is on and off switch. So there is no response here. Man, look, I am sorting this, but nothing is coming in response to what is there. So let me take you to the schematics and the doorway there. I will explain to you how to repair it. I will show you in detail. So let's come. So here is the schematics. I have this model. Okay, so what is our first step in this? What's your first step? It has to check the wing, which I tell in every video. So first of all, you have to check your wing, then come to the board here to check the wing. On the board, I show the win in the multimeter. After checking several videos, I explain two MOSFETs and a big SA resistor. Check the voltage. We're getting 19.8 volts. Verify and check everywhere for 19 volts. So there you have to check the voltage. So here I am checking the voltage. So here the complete voltage is coming. 19.8 volts is coming, means 19 volts is coming. So our window, okay, so we can check here. Also see here also any cape of 19 volts. You can check the line anywhere. Okay, so our win is okay. So now what is the problem here? Why is there no power? So now we will follow step. So let's do the schematics. What we have to see here, we have to see this. We have to look at this chart. What is this chart? We have to follow this chart. We are able to understand something here. Are we not able to understand it? But when I explain it to you now, you will understand this entire chart. And then you can read this chart from yourself. So here, first let me explain that S0 is visible, S3, S5, S4, S5, S4. This I will explain to you first here, if you will see how much we are showing S0 here. S3, S4, S5. Okay, now here I will tell you the details of what this SSSS is writing. This code is okay? This is the code of the voltage rail. So I'll tell you this secret. I will tell you in this video right now. No one will tell you this. I am telling you in this video. Then the video will be a little long, but you will know everything in detail. So see here, S5 is always ours. Before pressing the power button on the battery and the charger, the voltages in both of them come. Where do they come? I will tell you just now. S5, S4. These two voltages will be formed first. Then after that, if you press the power button, it will become S3. Then our S0, which is this S0, which is this S0, which is at the very last, which power reaches everywhere, our board gets on. Then this code of our S0 is applied. Okay, so now here our S5 and S4, these two things which are before pressing our power button. So here you can see that even before pressing our power button, we have to clear these two first because 19 volts is coming, but our one in the board. You have to see where the voltage is not coming. S5, S for such battery dose, not execute. This means that anyone has neither a battery nor a charger in it. So look here, neither our biswald is being formed, a cross is coming, nor look here, a cross is coming in the box in the line. And all this voltage is not being created by us, is it? This will not be a voltage either. Then there will be no voltage. So there is no voltage being formed over here. Okay, there is no voltage being formed here. Now look here. See here, battery, only battery. Now only battery, which is shown here. S for S5 is showing. But if it is seen, then our S5 is only, both have been given here. Then S5 is battery only. So see here, ours, which this voltage is coming, peace bolt is fine. If I tell it in detail, then your caffeine will be there. For now, know this much. I will tell you in the courts. At the moment, know this much about S5, S4, which is made on the battery and charger. It's so empty, you know. So both these are formed after installing the battery and the charger. Before pressing the button for the first time, if I look here, what is on our empty battery? The same voltage is being formed, which is 20 volts. But what is 20 volts comes on the charger. What is on our battery, which is 12 volts, comes on, okay? Here, see 12 volts, 10 to 12 volts. We have arrived, okay, on the battery. But when we install the charger here, see S5, S4. When we have installed the charger here now, AC means charger has been installed. AC power. Then after installing the charger here, this also became as if I was speaking S5. S4, okay. These two voltages have become Rs 4000. And here, see our S5, which has been made. Okay, S4 has not been made, nor here S5 has become ours. Now, after installing both AC here, we need these two voltages like I just showed you by installing the charger. In the board, we need these 20 volts and these many volts, these voltages, before we press the power button, right? Before pressing the power button, now it comes here, S3, which is formed after pressing our power button. Okay, S3, this is done. S3, this is done. Both of these will happen after pressing the power button. And this is S0. This is also the final voltage after pressing the power button. Okay, understand this coding is given. There is a coding of voltage rail. So to understand that, to understand this chart, then S5 is given so much. Remember S5 and S4, which is formed before pressing the power button. Okay, keep this blank attention. So now we will have these two checks. Our 20, I have checked you. Okay, so first of all, see here that I have not touched motherboard yet, but I have understood motherboard. Do you understand? I did not even touch motherboard, but yet I understood motherboard so much as what our voltage can become. In this board, this is the way to make it. So come back here. Now how much 20 volts is ours? 20 volts is ours. This is clear, okay. 19 volts was coming. Our is clear. Now we have to go further into this. Okay, we will check what is the first voltage. Always means there will always be voltage. Charge, okay. Charge, then if the voltage remains, then now what is our first voltage? 3 plus 3 volt. Always, then we will select it. Okay, we will search it, select it. Select it, copy it, go to find and search here. Now always, now here you have to understand that who is showing so much of our always, then who do we have to check? We have to check. Always this PC. This PC has to be left. This PC has a different voltage. Yes, for now it is showing PCA here. This is PCA here. So at the moment we have to check always empty, 3 volts, always plus the 3 volts, always. So if we click on the same, then first of all, it is already selected here. Then they used to come here. Now here, I explained to you that our 3 volts are not made here. This voltage is not made by us. This voltage, which is ours, this our 3 volts is giving to someone. See this. Passing through a register, 3 volts is giving pull up to someone, means giving power. This is giving power to this line. The register is installed. In the middle of it, it is going from here to this. Then this is not its birthplace. Means where this 3 volts is being formed. Then this 3 volts is not our birthplace, right? So let's come back down now. What are we going to check here now? Now let me say one more thing on this side. I can also make you check directly on the board. But to explain to you first, I am showing the schematic reading. Okay, you have got the schematic reading. So whatever board you are, you can easily make it according to Muskie, and no step is going to be missed by you. So then you came to another place. Where did you take it here? I told you this here. Does anyone see where this is clicking? Well, clicking on here, side down a little bit. See this here also, this one place is not. Okay, here also it is giving voltage to something here. Okay, then we will go to another place, side to another place. This is not a place of birth. That's okay. So we will go ahead now from here. It is giving this 3 volt voltage to BCC or IC. This is not our birthplace. This 3 volt has not been created here. See all these such presents here too. All these win all. One register for everyone. It is giving voltage to everyone by installing it in the middle. 3 voltage is going there, but you don't have to see it. Even if you come down again, you don't have to see it either. This is also not a birthplace. It is also pulling up the voltage, giving, okay, see here also, the register has been installed. It is also giving here. The voltage will go down. Look here also, a register has been installed. It is giving voltage here. Okay, it is giving, it is not being created here. It is not its birthplace. It is searching like this. It is not even here. 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 Not even here. You are seeing, you are not understanding. You are not able to read the schematics. You have not seen it here. You have selected it below, right? Giving pull up is not even here. And where is it has come here? I will scroll it a little bit and see it is not even here. Here, also not here, also not here, also not here. 1 second. This is also giving pull up. Okay, not here, also not here, also not here. This is block diagram. Okay, not here, also not here, also not here. This is block diagram. Okay, not here, also not here. What is this? The 3 volt is not here either. It is not here either. So it is giving right now. The register is installed. It is giving voltage here. Yes, you can see here. Where did one go? See here, what we have here is becoming free bold. Okay, why? How to tell this? See what is showing here. What happened to an IC? How is the coil? See how is the coil in the board? There is such a coil. Neither this is the same coil, nor this is the coil. So whenever we see 3 worlds, then we see it only on this coil. Neither this coil is the same, and it has come to this pad through here. The jumper is on the pad and showing 3 volts. Somehow see this IC is also giving 5 volts. See a coil has come here. Isn't it such a symbol? Such coil has come. It has come here. Our 5 volt always has also come from here. So these 2 things of ours are ahead now here. Now why are we going to use the board here? Why the board? Now why and how will we use the board? Now we remove the mouse. Now we have to find it in the board. Where is this thing? Isn't it to find us? We will select anyone who will take only 3 words. We will check this coil. If you will check it by creating a testing point, then what is the name of this coil? PL540 will select PL540, and here why I come to the board, see why we have the board available here. You can see why both the board and that board are showing the same. We have kept it like this. So here you have to go into the parts here and paste it and select it here. Now this arrow tells you here where this is at which place. Now if we come on board, then see here these two are showing Mercy. RAM is showing on the board. Then this coil, which is our 3 volts. See this, I do this. See our 3 volts is here. And the second 5 volts will definitely be here. And which is our LC. This is our PL5401. So let me install the charger. I connected this charger. It came unavailable. So now I am here. I will check the 3 volts. See, our 3 volts has come. Okay, now our 5 volts will also remain in the same way. So see, our 5 volts is also available. So there is no problem in both. This is our 2 voltages. So let me disconnect 4 people. Now come back to the schematics now here. I come back to the schematics again, and here I go up again. What has been checked of ours? What has been checked? Tell me. 3 volts have been checked. 5 volts have also been checked together. Now what is ours? What is the third number? Number 3 is our 3 volt PCH. Well, 3 volt PCH will copy it in the same way. After copying it, paste it here and search here. Now see here too, there are so many options here too. We have to do everything together. Only then will I be able to tell you in detail. You will be able to repair in detail. For this, that's why not everyone can make it quickly, but you have to work hard. All this here in seconds. Click here. Somewhere you can see how it is being made. No. It's okay. Not here, not here. There is a register here. It is giving full up, meaning some voltage is passing this 3 volts to some line. Band plus is visible here. What is this? This register, okay? 2 resistors got one and made a pack here. These 2 resistors are giving voltage at 2 places. It is not being made. It is giving. Something has been written here. See what voltage is giving here. Tell me what voltage is giving here.
It is being made here. Get up and tell me. It is being made or not. Tell in the comments. It is being made or not. It is not being made. Yes, okay. Now we will come to another one here. It is being made here. It is not being made. Very good. It is not being made. It is being made. It is not being made. It is being made. It is.
You are learning, sir. What is happening here? Let me tell you, it is not happening. Very good. Let me tell you here. No, tell you here. No, don't tell you here. Tell me here. It is not being made. Yes, tell me here. There is no call here. This direct is going to this. What is this? CPU is going into it. Voltage 3 volt pieces are not being formed here or not.
I'll tell you every step. I will make this board in half an hour. I can create an instant problem in half an hour, 20 minutes, or even in 10 minutes. But I am taking so much time to explain to you. I am creating in schematics. I am telling you what is happening here and what is not happening, right? Look ahead.
It is happening here. It is not happening. This direct voltage is going. Where is it happening here in the CPU? Tell me no. It is happening here. I will tell you why. Let's do interesting things here. You will get to learn a new thing. Look here, our 3 volt was always equal to 3 volts. Always, which is our jumper pad that came here from here. Both sorted by jumper is fine. And this voltage has become ours. PC, understand today? This same 3 volt has also become our PC. Understand the name has been changed by using a dumper. It belongs to any board. There is a mask flap attached here.
If such a MOSFET remains installed, then the voltage stays stuck from here to here, as if an enable is found. Then it goes from somewhere and forms PCH, or else he has made a direct here. That is, if the 3 bolts are blown, who is the boat day?
3 volts fly, 3 volts fly, then our sweep also flies. Do you know why it flies? That's why they give direct jumpers. These people, if our 3 volt goes, stops, becomes happy, then brother, this too becomes short.
Our CP, oh, sometimes you must have seen it is a 3 volt shot. It keeps making 3 volts. Malwa shots are happening. But it turns out, brother, here is the CPO shot, isn't it? If you see it here, then here, the CPO shot gets, because it is 3 volts connected, because it is always connected, therefore.
But the stock also got our PCH. Okay, our PCH has been found, means our 3 volt, which is going from direct jumper to PCH. So it needs to be checked. Tell me what? There is no need. Because if we check this, then we are going everywhere. Then this voltage must have become here too. Because there is no switching circuit inside the jumper. It is important to check it. So let us now check 1.8 volts. I am explaining to you this complete detail. You keep this in mind, okay? Write it down in the book pan. Okay, then our 1 point is 8 volts. Let's move forward. Now you tell me, is this voltage being created here? It is not being made here. What is not being made here? What is not being made?
It is not being created here because it is going to the CPU. All the voltage is not being created. Tell me that the volt pole is passing through here. Registration van 0.8 is being created. Is it not being created because the voltage it is getting is not the voltage it is getting?
Either it is getting from here or it is getting from here. The voltage is going from one of the two. The voltage is not going together here. Both are not going together. Okay, so we will come forward now. Then I will tell you. Choose a different problem. Tell friends, is it being formed here? Yes. The voltage is coming here. This voltage is coming here. The voltage is coming here. The voltage is being formed there. What is not being formed? Pull up. This is pull up. Okay. This is the head diagram. It is being formed here. It is not being formed.
It is being built here. Where has it gone? It is being built here. I will show you by zooming in. It is 1.8 volts. It is making it like this. Now, where is it making it like this? When is it making it? Why is it making it? I will now show you our all-time, what was it?
Our always was 3 volt, 5 volt, 3 volt PC, H 1.8 volt, always 1.05, always okay. 1.08 came on here, 08 and van. We will check this. Okay, at number 3. Now let's check at number 3. Let's charge this. I have charged. So now you will understand that we will keep saying like this. He will tell us directly where. But let me tell you the rating. So how to read it here? We have to check the 1.8 wall, or we will select it. Who will we select this contact? The jumper is a JP5 van.
5 double van. Okay, then we will test 5 van, double van here. And if we will make a jumper here, then this is ours here. This has been selected, sorry. I am searching here. You have to search here. Okay, I have to find a jumper tree. I have selected this one here, and this is our jumper tree.
Showed. Okay, now where is this ours? See this, where is our egg RAM? Coming to the side of the RAM, there is one this slot. It is right on the corner of the upper slot. Now here, if I show you up close, then see, here see this, see the name of our jumper is also coming. Like what name is coming? JP5 van is 44, right? The JP5 van is the 44. It is 11, sorry, JP is 511. Okay, so here we will check the search voltage van 0.8 volt. Here we will check van 0.8 word, then here 8 van 0.8 volt is not present here. See here any voltage which is not showing. Okay, here voltage is also not showing. See this double van is our AIC.
Now when the voltage here is not showing, now let us tell you what we will check. We will hit it. Tell us whether we will hit it or not. We will follow the steps. Now what are the steps to follow? Then come to the schematic again, or come to the schematic.
Now when will the IC work? When it gets a voltage, right? Everything will get a voltage, only then it will work. So here I check its voltage. We will go to its pins to check its voltage. So what is the voltage input here? Our VCC.
I will tell you in detail in the schematic. Here I am showing you to understand. Sorry, I will explain to you in the course in complete detail when I will explain to you what is the requirement of IC. All this is only then you will understand in more detail. Right now I am telling you here from top to top. I am telling you in detail only, but I am telling you through the methods of making this board. Okay, here, see what VCC means. You get the input voltage of an IC. Okay, if the voltage is obtained, then this pin number is on 27. So let's get pin number 27.
What will you do to see? This is IC, that pin number 27. This is our pin number 27. VCC clicked here. And what is connected to pin number 27 here? This is the KBC connection. Register, and this register is fine. Then here will come on the board. Then if in the board here, I put the charger here, I put the charger here. There is a capcitor here in the board. See our capcitor, then we have to check on our capcitor. If we touch this IC, then after touching the arm leg, our IC, which is can be short. So we will check the components outside of it. So over here, if I check how much is coming over here, the voltage is 2.5 volts. It was shown to you in the capacitor here. Don't say. See 2.5 volts coming here and to us. How many volts are 2.5 volts? Look here now, those caught here. Theft happens like this. You know there are some engineers who are not, now I am not saying this. Then every engineer is also bad. Some engineer who is like this, right? What do? This AC page will be applied. We will hit with the blower, and when we hit with the blower, what will the component registers on its side do? He will correct himself, and then he will pack it and give it to the customer. The customer will take it It will run for a week. As soon as that register comes to its status, it means that it is bad.
If it gets bad, it will come back to its original form after a few days. Neither when that register comes to its real form, comes in a bad condition, then it closes again and comes again. Then the guy will hit, then it will run, right? So what will he do? If this happens, he will remove the IC and install another IC.
He is going to be busy for the entire day, week, month, or even 2 months. So here I am reading to you and showing you that you have the same issue where the problem is. Don't beat yourself up over it. So let us have 5 volts, that is 5 volts that we should have here, 2.5 volts. So if I also have the board, then one register is here and one register is here. If we will see in the motherboard here, then what is ours? One is Kapikiter and the other one is nothing, means what is here is nothing. This is the registry. I think the register here is missed. How will you identify it now? There's no voltage here. No power is being generated, so how can we find it out? Let me show you in the schematics. This wasn't addressed before. I'll explain. If you look closer here and zoom in. Yes, Choice Jumal, if you will notice here, a fault voltage has gone to the register. A 5 volt has gone to the register at the same place. Now here, what is the common in both the registers? What is the difference between these two registers? See whether there is any difference. There is no difference. Do you know the difference? This is the difference. See if there is a direct attached. It is attached to this register, which means there may not be a component here. It may be okay, and no one has been given in this place. So which of our registers is pulling it up?
PR520, PR502. This is not where we were checking. Right now there is a missing part there. Then this is the missing part. Here the old part has not been given already. Then by reading the schematics, you know that there is nothing here. There was not even before.
Well, now here we have this register firewall VPL always happens. So let's see which of the two registers are engaged in this. They check the register. We have selected this register. Okay, God has selected it, went to it and pasted it here. Okay, see this if you As you can see here, I have changed the register. Here I have put a big little register of 0 ohms. So now here, if I show you the voltage here, then look here. Our 5 volt has started coming here. Look, I am touching it. 5 volt is coming, right? I am touching this capacitor. Then our 5 volt is coming available. Okay, so now the board that we have here is also directly turned on without power button medicine. See this. Our board is also on AC recharge. Because of CMOS, you can see on there our board, which is turned on by itself. Our reading has become normal. Well, our laptop is on, but look, it's restarting. CMOS. Our motherboard will be on, so have you seen how I have made this motherboard step by step? Well, similarly, you follow my channel and you will also learn to follow the schematics.